a new theory that one single asteroid collision may have caused the Earth, Mars, and even the Moon to wobble around and rock. This is concerning new evidence from Southwest Research Institute. We all know that we have a tremendous amount of scarring on our Earth and even the Moon and Mars. Could it have been from one instance? A shattered asteroid that may have unleashed cosmic barrages that left scars in our inner solar system, possibly changing, of course, Earth's history, Earth's geology. A violent collision by an asteroid may have sent frequency and waves of debris sweeping through the inner solar system. This could have happened about about 1 billion years ago, 800 million years ago, and affecting the Earth, Moon, and even Mars. This is concerning what the findings of a new study by Southwestern Research Institute claims. They connected ancient bombardments to the breakup of a cosmic body they call Eulalia. It was supposedly a very large object in the main asteroid belt between Mars and Jupiter. And from what the researchers found, the collision may have produced a huge supply of fragments of debris that later crossed the paths of rocky planets. And this cosmic event could help explain why there is an increase in large impact recorded in the Moon from the same period. It may have, of course, a geological and biological consequence on Earth, although evidence from such an ancient era is not easy to preserve. The role impacts played in shaping origin and evolution of life in our solar system is not understood at all well, said Dr. William Bucht. He is the executive director in SWIRI Solar System Science of Boulder, Colorado. And he also directs the Center for Lunar Origin and Evolution, CLOE for short, SWIRI's team in NASA's Solar System Exploration Virtual Institute. He's the lead author of this new study. He says, the heavily cratered surface of the Moon serves as a reminder of large impacts in Earth's past. But only the Chicxulub impact event 66 million years ago, we know that was the event that supposedly put an end to the dinosaurs, strongly linked to the specific effect on life on Earth. The Chicxulub is the most famous example of an asteroid impact that affected life on Earth. And that asteroid struck near the Gulf of Mexico, and of course it caused an environmental change associated with the disappearance of the dinosaurs. And researchers suspect other such impact episodes may have caused the planet's climate, geology, and of course living organisms to have an extinction event. So these connections have become much harder to prove since scientists look further back in time, because of course a lot of these evidences have disappeared. Earth does not preserve its surface as neatly as the Moon does because of our plate tectonics on Earth, and land masses continuously move, recycling sections of the crust. Also, volcanoes create new land masses and terrain, and we also have erosion, removing older land formations. And because of the renewal, geological evidence of our impacts older than about 650 million years is difficult to prove. Many ancient craters could have been distorted or destroyed. But the Moon is more stable in its record. It has no plate tectonics, it has no flowing water or atmosphere to erase features, and its surface keeps the scars from impacts that occurred billions of years ago. So these rare events caused by large collisions in the main asteroid belt and large bombardments in the inner solar system are evidence which is preserved on the moon's static surface. And we can use that to infer what could have happened on Earth and Mars in the ancient past. What about the Apollo impact glass? Past research tells us that the moon experienced a rise in large impacts about 800 million years ago. This proof comes from estimated crater ages from impact glass. This glass was collected during the Apollo missions. And this impact glass forms when energy from collision melts rocks almost instantly, and the molten material cools and hardens, preserving a timestamp of when exactly this event took place. So the question was where the objects responsible for the apparent spike came from. And they said our forensics team used collisional dynamic models to link these formations of the Eulalia asteroid family when primitive carbonaceous chondrite-like objects collided with another object. The location of the parent asteroid was key. It broke up on the brink of the gravitational 3-1 mean motion resonance with Jupiter. So these primitive space rocks that contain minerals left over from the solar system's formation, this asteroid family is a collection of fragments that have similar orbits because they originate in the breakup of larger body of a parent body. And there was Jupiter's gravitational escape route. The Eulalia body appears to have broken apart near an important orbital region known as 13-1 resonance. An asteroid circles the Sun 3 times during each orbit completed by Jupiter. In this area, repeated gravitational pulls from the giant planet Jupiter could destabilize an asteroid's path and eventually push it out of the main asteroid belt. This makes the 13-1 resonance a kind of gravity escape route. And once the object enters it, their orbits can shift into regions that are not constant, and they head towards the paths of the inner solar system, Earth, Mars, and other planets. So the researchers simulated this to find out if this could have happened with the Eulalia fragments entering this resonance. The bombardment lasted millions of years, they say. There was a sharp increase in the number of impacts on the moon and the terrestrial planets for over 100 to 150 million years. The models say that another 25% of debris moved into the 13-1 resonance. You can imagine what was going on around that time, 800 million years ago. The migration was driven by the Yarkovsky effect. This is a subtle force caused by heat. When the asteroid is heated on one side, and that means it rotates differently, it changes its journey, its asteroid path, because an asteroid absorbing the sunlight later releases that energy as radiation. So this tiny push makes it uneven in its path and gradually alters its path and its orbit over longer periods of time. So the results show that the breakup of this Eulalia parent cosmic body could explain the increase in lunar craters about 800 million years ago. And the same could have also been acting on Earth and Mars for a prolonged barrage of asteroids. What was the possible effect on Earth and Mars? The overlap does not prove impacts cause those changes. Given the peak of the barrage coincides with a period of widespread cooling and major shifts in our biosphere, it's tempting to suggest that the former produced the latter. On Mars, there were major impacts that could have generated seismic waves similar to powerful earthquakes. Scientists found that the timing could coincide with volcanic activity increase, suggesting this bombardment could affect the planet far beneath its surface, just like it would have done with ours. So when they take all of this together, their findings have a broader view of one collision in the asteroid belt may have, I guess you can think of it as similar as billiard balls. With your cue stick, you hit one ball and it just goes shattering into others. So a shattered asteroid near a gravitational gateway could send debris across the inner solar system, leaving marks on the moon, and of course, geological and biological histories on our Earth and in Mars. And this was from Planetary Science Journal by William Buck and David Melissa Nichols-Zeller. It has to do with the new findings of one collision that could have really rocked Earth, Mars, and the Moon. This is by Southwest Research Institute, SciTech Daily. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.